The logarithms have similar rules to the rules that you see when you're working with exponents. So like for example, we know that if two bases are the same and you're multiplying them, the rule is you gotta add the powers with one another and you get x to the power of 9, for example. Well, there is a similar thing happening in the logarithmic world. Okay, so this table is something that you're gonna have to memorize in order to be able to do the next few problems and in order to be successful in this chapter. So, the first one, the second one are super important. They're called the product rule and the quotient rule. Be careful what they say. The product rule pretty much says that the log of a product is the same thing as the sum of two logs. The second rule basically says the log of a quotient, the log of a fraction, is the difference of two logs. So it allows me to basically break numbers off and separate them into their own logs, or vice versa. If they're already separate, I can put them back together. The third rule over here on this page is what we call in this chapter the power rule. It's the rule that says if you have a power, you can take the power and stick it in front. Or if you have a number in front, you can stick it in the power. It's up to you. Okay. So those are three really important rules. Now, I mentioned that we can plug this into the calculator. How do you plug it into the calculator? Well, you will need to do a change of base formula because most of the calculators don't have a button for log base 2. They have log, which is log, and they have another one button called ln. And so in order to be able to plug something like this into the calculator, you have to use that last formula called the change of base formula. So more on that later. These two are kind of useful because they tell me the log of 1 is always 0. So in other terms, this one says you will always pass through the x-axis at the point 1, 0. That's basically one of the rules. And the other final rule that is written here pretty much says if you have log base a and there's a base a again, then the answer is going to be k at the end. How come? Why is the answer going to be k? Well, think about what it means to write down log base a of ak. This means we're looking at what power you put on top of this guy a to make it equal to the argument ak. Well, in that case, it's kind of obvious. The letter or the number should be k because that's the number that is written on top right here anyway. So take a minute to write these down and memorize them because we will use them in the next page pretty much over here. Okay, so I'm going to pause the video for a second, take a look, memorize them, write them down, and let's start with working with example 4. So let's take a look at how we can use those rules above. They have told us that log base a of 2 is equal to 0.301 and log base a of 3 is 0.477, and they want us to find each of the following. So the very first one says log base a of 6. So here's what the plan is. The plan is to think of a way to write down 6 either as a product or as a division of the numbers that we have here. So it is obvious, I hope, that 6 is the same thing as 2 times 3. So that's pretty straightforward. 6 is 2 times 3. And notice that I'm writing 2 times 3. So this will involve using the product rule that is written up there. So according to the rule, I'm supposed to write down log base a of 2 plus log base a of 3. Okay? When two things are multiplied, we turn the problem into addition. And by the way, log base a of 2 is 0.301 and the other one is 0.477. So all I have to do now is put them into my calculator and get the solution. Okay, so looking at the second one, it says log base a of 2 over 3. Whether there's parentheses or not does not matter, but what I want you to notice right here is that there is a fraction. So on this problem, we're going to be using the quotient property or the quotient rule. Okay, and according to the quotient rule, we will be writing down log base a of the numerator minus log base a of the denominator. Okay, so this was called quotient rule. And keep in mind that the first one is 0.301, the second one is 0.477, and when you subtract them, you put this in your calculator, you're going to get negative 0.176. And that's the solution right there. Okay, so these were called the product rule and the quotient rule. Okay, let's keep going and take a look at the next one. The next one has log base A of 81. Okay, there's a lot of them, but let me do one more and then we'll stop the video and start another video. So log base A of 81. So in this case, I should think to myself, is there a way to write down 81 as a product of 2's and 3's, or maybe as a power of 3 or a power of 2 or something like that, okay? And I hope that you remember from other classes or just from life in general that 3 to the power of 4 is exactly 81. So I have 81, which can be replaced with 3 to the power of 4. Now, why would I want to do this? I want to do this because at this point, there's a rule called the power rule, which allows me to take an exponent and write it in front of the log. So I can move the 4 to the front and write down log base A of 3. Okay, now what's between the 4 and the log? It turns into a product. So this is called the power rule. And by the way, the log base A of 3, that's 0.477. So 4 times that amount is going to be at the end 1.908. So that's the final answer. Okay, so like I said, I'm going to stop the video here and start a different one for the rest of the problem. So I hope this made sense so far.